Hello, everyone, and welcome to today's webinar. We're thrilled to see so many of you here to learn about Amazon Kendra. We've got some great information to share with you today about intelligent search. I'm Justin Freeman, Senior Partner Development Specialist with AWS Catalyst, and I am joined by Nikhil Shetty, a Senior Product Manager from Amazon Kendra. And the topic of our discussion today is how you might be able to improve customer experience in your SaaS application with Amazon Kendra Intelligent Search. Nikhil, why don't you tell us a little bit about yourself?
Thanks, Justin. Hey, everyone. I'm Nikhil Shetty. I'm the Senior Product Manager for Amazon Kendra. I've been with AWS close to 2 years and been building cloud services for the last 4 years. As a PM at Amazon Kendra, I've helped build features, shape the roadmap based on customer feedback, work with data scientists to improve the search accuracy in Kendra, and help onboard multiple customers onto the service. And I'm excited to share today on how you can use Kendra to build a powerful search experience in your SaaS applications.
Thanks, Nikhil. And again, I'm Justin Freeman, and I'm a new kid on the block here at AWS. Only been here for a few months, but have been super excited to learn more about Amazon Kendra in my short time here. Nikhil and his team are fantastic and have a really great product that we're excited to tell you a little bit more about today. Kendra, just a little background about how we got started, what we're all doing here. It was built out of a consistent customer feedback from enterprises. They were having significant frustrations around this lack of relevancy in their search results. Basically, organizations were continuing to pile up more and more and more data to their searchable indices, and keyword search was facing an increasingly hard time, more difficulty keeping up with relevance. And so there was this growing digital access to information, but also a growing difficulty in the ability to retrieve that information with relevant results. So on top of that, users are becoming more and more accustomed to a tailored search experience with features like type ahead suggestions, spell checking, synonym checking, query suggestions. All of those things were gaining popularity, and traditional keyword searches were unable to meet some of those demands. So our Kendra team heard those demands and created a solution that introduced the power of machine learning right into the search experience with many of the key features that those users were demanding. So rather than pinging for specific keywords, Amazon Kendra was built to crawl that data routinely, comprehend it through natural language, and deliver relevant results with machine learning algorithms that were powerful right out of the box and gained even more power over time. And perhaps most importantly, Kendra addresses all of these pain points with an out-of-the-box solution as a managed service. So the team's made it extremely simple to connect to Kendra and begin using it immediately. And so far, we've seen amazing results with our enterprise customers. And we've now added multi-tenancy as a cost-effective gated feature for Amazon Kendra. That now empowers SaaS companies such as yourself to leverage our machine learning to your embedded search solution today. And so throughout the course of our presentation today, we'll talk about how we can help you do exactly that. And let's get to our agenda. So we've got a packed agenda for you today. We're going to talk about some of the key challenges that are facing in search. We've talked about some of that already, but let's dive a little bit deeper and talk about how Amazon Kendra solves some of those problems. We'll also go through a few demos that Nikhil's prepared for us today that really show off some of the powerful features that you can utilize with Amazon Kendra. We'll also talk a bit more about multi-tenancy, the real key gated feature that unlocks Kendra for ISVs with multiple end-use customers. We'll go through some ISV use cases and benefits, and then we'll also go through next steps on how to set up a POC. So if you're interested in moving forward with Kendra, that's what I'm here to support, and I would really love the opportunity to continue a conversation with you from today's webinar. We'll end with a Q&A, so if you do have questions, feel free to type them into the chat. We'll either answer them through our live Q&A, or we'll reach out to you after the fact, after our webinar today, if we're unable to get to your question in time. We definitely want to make sure you walk away with all questions answered. Just so you know, this is an anonymous Q&A, so your company or your name will not be disclosed throughout this. Really appreciate everyone being here. Now I'll send it back over to Nikhil.
Thanks, Justin. So our mission here at AWS, and specifically the AI org, is to take the deep and rich experience that we have using AI across all of Amazon and put it into the hands of all of our customers at every level of expertise, be it a developer who's trying to add intelligence to their applications, or a data scientist who's trying to build machine learning models and deploy them at scale, or it could be a researcher who wants to develop on their choice of frameworks. We want to democratize AI for everyone. Kendra is an intelligent search service that enables developers to build powerful search experiences without having to require machine learning expertise. Kendra uses machine learning and natural language under the hood to produce highly accurate search results out of the box for data that is scattered across repositories. Now, when we spoke to customers to understand the challenges in search, there were two things that we heard very loud and clear. One is that most traditional search engines suffered with a lack of search relevance or had very poor search relevance. Now, end users, when they are searching, they expect a web search like accuracy. They expect the search engines to understand what they are looking for, figure out their intent, and find the information that they want instead of getting 10 blue links and having to figure out the information on their own. Users also expect the engine to understand their behavior, improve results over time. Search admins, the people who deploy search, they want to tune relevance in a way that makes sense for their business. And all of these things are becoming more and more challenging with keyword search. So imagine a SaaS application for a contact center where an agent is not able to find the answers that they're looking for while they are on a call with the customer. Or think about a knowledge management and collaboration tool where employees create documents, but then have a hard time finding those documents that they or their peers created. So search is very, very critical experience for a SaaS product and can make or break the product. The second big thing is what we've heard is that there is a lot of management overhead in building and running search applications. So this management starts from the lowest layer of managing the infra, thinking about how many machines you need, how many clusters, how many shards, how many availability zones do I keep this across? How does all of this change when my content grows or when my query traffic grows? I need to reshard everything, rethink about all of my infrastructure. Then I also need to think about how do I bring my data into the index or into the search index? And it has to be up to date all the time. It has to be available immediately. I also need to think about building search features like faceting, filtering, query suggestions, and many more. And if you're building AI/ML models on top of it, that's additional work that needs to be built and managed and maintained. And customers see a lot of this work as undifferentiated that their teams can move away from. So we built Kendra to basically solve these problems. And I want to highlight 4 things here. First is Kendra has natural language understanding and semantic search out of the box, which gives you a very, very high search accuracy. So for example, what I mean by semantic search is if you give a document to Kendra, Kendra really understands the meaning of the document and not just the keywords that are in that document. So for example, if a document talks about configuring VPN, Kendra understands that this is about some tech configuration, something about networking, versus just looking at keywords and storing the keywords there. Likewise, when a user is asking a query, like how do I configure my VPN, Kendra is able to understand the query, it understands the document, and is able to surface the right document to the user along with the extracted information from that document. So this results in very, very high productivity for end users as they don't have to navigate through multiple blue links to find what they're looking for, but find the information up front. Kendra is pre-trained on 14 different domains and industries, including healthcare, technology, IT, hospitality, and many more. We've also trained it on a large list of global synonyms so that Kendra understands things like networking and connection are probably the same thing. Dog and canine mean similar words. Roof and ceiling are very close words. All of these things are already inbuilt into Kendra's understanding. The second big thing is Kendra is a fully managed search service. So all of the things that we talked about earlier, managing indexes, managing clusters, availability, shards, all of that is completely abstracted away from the customer. So in this case, if you're using Kendra, all you need to think about is how many documents do I have and how much query traffic do I see? So for example, let's say you have 10 million documents across 1,000 customers and you see about 100,000 queries a day. You can provision a Kendra index to say, okay, I provision an index that has a capacity of 10 million documents and 100,000 queries per day, and that's where you stop. And we manage the performance, we manage everything. And as your query or document capacity grows or requirements grow, you can easily add document units or query units, and you can scale both of these dimensions independently over time. And you can also automate the scaling. We also have inbuilt search features like query suggestions, query spell check, analytics, faceting, filtering. All of these things are just a configuration away from making it available to your end users. The third thing is secure search. So apart from having enterprise security features like encryption at rest, encryption in transit, ability to bring your own keys and encrypt the data, we also have a very, very important thing that our enterprise customers always ask for, and which is support for access control list, which means if a document has restricted permissions and only few people have access to it, then if a user is searching that user will not be shown documents that they don't have access to. And that's because when Kendra ingests these documents, it also ingests the ACL information. It understands that user A has access to so-and-so documents, user B has access to some other set of documents, and it'll always respect that and honor that to make sure that they are not shown any unrestricted documents. This comes out of the box without you having to build extra features on top of the search engine. And last but not the least, tuning and customization. So this is where we give you the ability to build the search engine or the search solution in a way that makes sense for your business, for your use case, for your customers. And this tuning goes from very simple basic tuning to very advanced tuning. So simple tuning can be using document metadata attributes to boost the results. So as an example, if you have some documents that coming from a particular data source or an author, and you know that they are curated and they are very well written and they always have more authoritative content, you can tell Kendra to boost the results that are coming from that data source or from that author. Likewise, if you have a date field that says when the document was created, you can use that to say, well, always show the most recent documents to the top so that stale information is not the first thing that the users see. Advanced configuration or advanced customization can enable you to use other AI/ML services or even your own custom code to modify the data before it is indexed into Kendra. For example, you could take a video or an audio, take the transcripts of it, modify it, add some metadata, enrich it with some metadata attributes, index it into Kendra, and make it searchable. You could take images, extract images out of it, put that into Kendra. You could extract sentiment, you could extract keywords out of documents using Comprehend or even your custom code, put them into Kendra and make all of that searchable. Now, when you ask a question to Kendra or send a query to Kendra, Kendra returns three types of results. The first one is an instant answer. So as you can see, if I ask something like, where is the IT support desk? It found a document that says the one in Kumo is on the first floor. So it inferred that the IT support desk is on the first floor, and it extracts the first floor as the top answer, the instant answer, and puts it right at the top. So for a user, they don't have to navigate or look at the document or even click the link to find out the information that they are looking for. The second set is frequently asked questions. So you can upload to Kendra a set of FAQs that are relevant for your organization. And every time a query hits the Kendra index, Kendra will look at all the FAQs and surface any semantically relevant questions to the user's query. So for example, in this case, Kendra found 3 FAQs that are somewhat close or similar to what the user is asking for. So when I say, where is the IT support desk? You get questions like, where do I get help, IT help in Kumu? Or what are the IT support asks? Very close to what the user is looking for, probably the next question that they have about the information that they're looking for. And of course, like traditional search engines, we also give a ranked list of documents, but with the added advantage of those being semantically relevant and not just documents that have keywords within them. Now let's look at a few demos to see how this works. So for this index, what we have done is we have indexed content that contains information about AWS products. And so I'll ask a few questions about the same. So for example, if I ask something like, which service has 11 nines of durability? Kendra is able to find the exact answer. It found a document that says Amazon S3 has data durability of 11 nines. So it found that, and it found the exact answer, surfaced it right at the top. It also found an FAQ, which asked the question, which service has, very close to what we are looking for. And then it found a list of other documents that also talk about the high durability of S3. There's a blog. There's another link that talks about similar information. Another thing you will notice here is some highlighting of keywords. So the interesting thing is Kendra understands that while semantic searches or semantic relevance is important, we also understand that keywords are also important. And what you're seeing as highlights are actually keywords in the query. And so when we give you results, we always strike a fine balance between giving you documents that have the keywords, but also have the semantic relevance to the information that you're looking for. And as you can see, you have the standard features of faceting and filtering. You can do sorting based on which attributes you have decided to sort on. You have thumbs up, thumbs down features that I'll talk about a little bit more. So let's look at another example. So if I add something like well-architected So in this case, as you can see, the question is very open-ended. It's not really a question, it's just information that I'm looking for. And so in this case, it found an FAQ that says, what is the AWS well-architected framework? Pretty relevant to what the user might be looking for. Found a white paper and a few other documents that talk about the well-architected framework. Now let's make this a little more specific. So if I say, when I make this specific, it finds the answer to what the user might be looking for. So it identifies the 5 pillars in the document right up front, and you can see that in the blue highlight. And again, once again, you see all of the black highlights that are keywords in the user's query. Let's try one other query. In this case, again, I asked a very factoid question. It pulled out a factoid answer. But let's see how this behaves when I change some things a little bit, because not all users may ask questions the same way. They may not have words that match what's written in the document. So let's see if I say, how much traffic in DynamoDB handle per day? Still found the same document with the blue highlights. It can take 10 trillion requests per day. Let's change this a little bit to just keywords and not really a question. So I'll say DynamoDB requests per day. Because users, again, not all users may use natural language questions. You might just ask, because you're used to keyword searching. So again, you just say DynamoDB requests per day, and you're still finding the answer that the user's intent, that matches the user's intent. Then we also support, in terms of the types of documents that we support, so we support HTML, PDF, PowerPoint, Word docs, text, and you don't need any analyzers or parsers. It's all inbuilt into Kendra. So Kendra uses user feedback to improve search results. We have a feature called incremental learning that is tracking user behavior, seeing what they click on, seeing what they give, like or don't like, and use that information to make the results better over time. So we collect 2 types of feedback from users. One is explicit feedback, the other is implicit. Explicit feedback is where we give users a thumbs up or a thumbs down button in the search UI, so where users are explicitly telling us that, hey, I like this result or I don't like this result. So for example, if for a query, a result number 3 or 4 is consistently picked by users and they consistently give a thumbs up to it, that result will be pushed up over time so that the next user, when they come and search for the same thing, they see a better result or a result that other users have liked. We also take implicit feedback because not all users may be motivated enough to give a thumbs up or thumbs down. But implicit feedback is where we track the clicks on the results. And we use that information as well to push or boost results on the top to make results more and more relevant with time. We have an analytics dashboard in Kendra, very, very critical to track what the search performance is of your users is, whether they're liking the search, whether they're finding the content they're looking for. Is there content that they consistently look for or all users are looking for that's not there in your doc corpus? So we have metrics like click-through rate, which tells you for each query whether documents were clicked or not. We have zero click rate, which tells you, for what percentage of queries there were no clicks. Instant answer rate, like which queries produced instant answers. Top queries. This is an interesting one where you look at, what were the queries that were most asked by users. And you can look at corresponding metrics like click-through rate and instant answer rate to figure out whether they are finding the content or finding the answer or information that they're looking for. And if not, you can take that as a feedback and add, either modify your corpus or add some documents that answer what your users are looking for. You can explore the analytics, all the metrics within the Kendra console, or you could also export all of these metrics into an analysis tool or analytics tool of your choice through our APIs. We have, so I talked about tuning and customization. So we have a way, a simple way to tune results. So Kendra today allows a few different types of attributes or metadata fields for document. They are string, string list, all of a text, numeric, and a date type. So if you have, let's say, a text attribute, you can use that to boost results. So in this case, we have, as you can see, there's text attributes like title, author, description, category. You can assign tags. You can use all of this information to say, for example, in this case, there is a data source called marketing documentation. And if you know that that data source has generally very good content, you can boost that that setting to say that data or documents coming from this data source should always be shown higher up to users so that they find the right information. You can also use metrics like if you have numeric metadata attributes like view or like counts, you can use that information to boost results. So if you know that the document is very popular, has been viewed many times, you can just boost that in ascending order here. So in that case, it will boost those documents to the top, and users will see what most popular documents exist in your corpus. And likewise, you can boost based on document freshness as well. You can either say, well, show me the most recent show your users the most recent documents, or recently modified document, recently created document. You can use the date field, as it suits your business need. So let's look at an example of how tuning works. So you can tune results in Kendra, like you saw with the simple sliders. All of that are in the dashboard right next to a search console that you can use to change those settings. So in this case, what we have done is the index has taken sales data for various drugs across different regions. And so what you're looking at is the search console, which you can use to quickly test out some queries. And you'll also notice a few things here. Like, for example, as soon as I enter in the search box, you see suggestions are ranked by popularity. So if I say sales, as soon as I type something, it is giving me a few suggestions. So these are based on all the queries that have been asked by users before. And that helps the next user to guide them towards the right query and eventually guide them towards the right content that they're looking for. So in this case, I'll just say sales for ibuprofen. So what you see is sale of ibuprofen in UK, in Japan, in Mexico, again, Japan. So these are all coming by different countries. And if I expand this a little bit, what you see is document fields here. You have country, product, salesperson, and all of these have assigned values. Like in this case, it's UK. In this case, it's Japan, and so on and so forth for all the documents. Now let's look at what tuning I can do here. So let's say I want to boost results for a specific country. What I can do is I find the field with the name country, and I boost this to, let's say, a value of 10. I add the value because I want to boost a specific country in this case. So let's say we say UK. Save. Change this to 10 as well. And now if I run the same query again, now you'll see that all of the results from UK have been boosted to the top. So the first result is UK, the second, third, fourth. A lot of results are from the UK. In fact, all documents on this page belong to UK. Now, the way you can use this is, let's say if you have people searching in the UK, in Mexico, and these are all different users, and you have queries coming from all of these different regions, you can tune the relevance differently for all of these different users. And what you're seeing now is an index level setting, but you can change these tuning at a query level as well. So for example, if there's a user querying from Mexico, you can change the boosting for that user to say, well, boost all the documents from Mexico. Likewise for UK or Japan, and you can have different boosting settings for different sets of users. Another thing I want to show you here is, let's say if I change this to, say, ibuprofen with an incorrect spelling. So Kendra is able to detect that there was an incorrect spelling here, and the right spelling or the word that exists in the corpus is ibuprofen. Gives you that suggestion. Users can click on that and then navigate to the right query and eventually the right information. Now we also have ways, advanced ways to customize your search results in Kendra. What you saw with tuning is a slider mechanism. You use metadata information to boost results. But there's a lot more possibilities when you use the custom document enrichment feature in Kendra. So it's a very busy slide, but the way to look at this is everything you see on the left is all ingestion and document enrichment. The second one is tuning. Once you have the documents into Kendra, then how do you tune the index? And the third one is how do you deploy and make the search application available to your end users? So let's start on the left. So you have all of your data sources. Let's say you're using one of Amazon Kendra connectors, which can crawl these data sources and bring the data into Kendra. So as it is bringing this data into Kendra, there is a step where you can add enrichment to your documents. Now, there's two types of enrichments you can do. One is basic enrichment, which is a set of simple if-then conditions to say, for example, if you have, let's say, 10,000 documents and 500 of those have no dates, and you just want to assign a default date to them, you can create an if-then condition to say, if the document has no date attribute set it to some default value. Or let's say if you have document titles which contain the author information and you want to use author information as a metadata attribute, you can say, well, while you are ingesting, extract this information from the title, put it in the metadata attribute, and then index it into Kendra so that it appears as a facet. I can use it for boosting, I can use it for filtering, and so on and so forth. So this is basic enrichment. In addition, you can also do advanced enrichment using Lambda. So you use a Lambda to make calls to either other AWS services or custom code that you have written that extracts or modifies the document in a way that makes sense to you and your business. So as an example, you can use Amazon Comprehend, Amazon Textract, Transcribe, Translate, Recognition, all of these services. For example, let's say if you have documents wherein you want to detect some medical entities, let's say you have policy documents, and you want to extract policy numbers and use that as metadata, you can use Comprehend to detect those entities. If you have scanned PDFs or scanned images that contain a lot of text, you can use Textract to take that text out and send that to Kendra. You could use Transcribe for audio and video content, take the transcript out and index it into Kendra. Likewise, you can translate documents. You can use recognition to find information embedded into images and make them searchable. And so the possibilities here are pretty much endless, in terms of what you want to do and what are the tools that you have at your disposal to be able to modify or extract more information from your document and make them all searchable. Once your documents are within Kendra, there's a few different things that you can do to further customize your solution. So we talked about incremental learning. You can configure the index to track user behavior, or you can choose not to do it if that makes sense to you. You can do relevance tuning, like we talked about earlier. You can use metadata attributes to boost results or push results up or down. There's also a custom synonyms feature in Kendra. Where this helps is if you have, let's say, acronyms within the organization, like something like NPL can mean new product launch. You can tell that to Kendra so that the next time when a user is searching either NPL or new product launch, Kendra understands that these two are the same thing, and it will find documents that contain both of those things. You can use it for even words that have different meanings within your organization to tell Kendra, well, this word can mean 10 different things. Particularly useful when you have drug information where a drug can have 10 different names, a chemical name, a commercial name, and you want users to be able to search through all of those without having to explicitly say that, hey, I want documents that contain this name as well as that name. And then you deploy this search application to your end users, make it available for them to search. So let's look at a few examples of how you can use custom document enrichment feature. So I'll go back to this search demo. So in this search index, we have also indexed a few documents to show you specific demo to this. So for example, if I search, there is when I search where is Yosemite located, it found me a page that talks about Yosemite being in California. You can see the highlights. Now, when I click on the result, it looks like a wiki page. But what this really is, it's actually an image. What we have done is we just took a screenshot of this page on Wikipedia. Then we use Amazon Textract to extract this information and index it into Kendra. And Kendra is able to use that information to find the exact information that you're looking for. Let's see another example. Say I want to configure VPN. So in this case, the actual content or document that you have is a video. And what we have done is we are using transcribe to take that video, take the transcript out of it, send that to Kendra and make it searchable. And we built a search application in a way that the video automatically scrolls to the point where the content being spoken about is very relevant to what the user's query is. So in this case,
you will have encrypted traffic from your on-premises network to the VPC.
As you can see, it directly starts at, it's about an 8-minute long video. It directly starts at 7 minutes, pertinent to the information that the user is looking for, without them having to see through the entire video to find find the relevant information. So let's look at another example of how we've used custom document enrichment. So in this one, we have indexed all information from a wiki page that contains information about drugs recommended by the World Health Organization. So I can search something like for So if I say treatment for diabetes, it is finding me the document that talks about insulin. But here's the interesting thing. So if you look at all the facets, you see anatomy, medical condition, medication, and you see various values here. Now, all of these values are actually coming from comprehend medical, detecting these entities within the documents. So at the time of ingestion, we invoke comprehend to say, well, find me all the all the different values for anatomy in this document, likewise for medical condition, medication, and all of that. And all of that is used as metadata attributes during search. Now, when we go to ISVs and we talk about all of these features, they say, well, we like Kendra, we want to use this as an embedded search into our SaaS application, but we want to deploy this in a multi-tenant way. So, before we launch multi-tenancy, customers would have to create, let's say, you're a SaaS provider, you have 1,000 customers, you have to create 1,000 indexes within Kendra, and that makes it hard to manage and also inefficient because not all customers, because many indexes are not used at full capacity. And so what we were really asking for is, well, how do I make optimal use of resources in Kendra and be able to serve 1,000 customers with all of their data isolated? So what we built is a multi-tenant index where you provision an index and you can split that index into many smaller indexes that are isolated on their data and their permissions, and you can map each tenant index to each of your end customers. So let's say you have 10 million documents across 1,000 customers. You can provision a single index with 10 million document capacity, and then you can create 1,000 smaller subdivisions within that index. And each of those units can take as many documents as they can, up to a limit of 10 million. And then you can easily add more and more document capacity as your capacity grows. You can share the query traffic or query capacity that is available across all of these tenants. All of your data across customers is completely isolated. You have separate permissions for each tenant. So customer one, when they query an index, they're not able to see customer two's data. Likewise, features like query suggestions, spell checking, all of those will be scoped within the boundary of the tenant index. But you do have the added advantage of being able to share the capacity and make the optimal use of the capacity that is available on an index. And what you can do with this is, any SaaS application provider can use this feature to embed Kendra search into their application for their end users. So this could be a contact center application where an agent is looking for answers as they are attending to a customer real time on call, or it could be a knowledge management and collaboration software where employees create documents, share those documents, and then want to find those documents quickly. Or it could be used for an ITSM tool where an engineer is trying to resolve tickets and they want to find relevant information quickly. Likewise for CRM, sales and marketing, and many more. What this means for you as an ISV is higher adoption and retention of your end customers. Search can be a very, very critical function. All of their data is in your repository, and making them searchable, visible is extremely critical for your end users. And when they get a good search experience, that means higher adoption, better search experience for your end customers, and more retention. Low operational overhead for your engineering teams. So, Kendra takes away the undifferentiated work of managing clusters, managing search features. All of that, we have solved those problems for you. So that you can now focus on making or tuning or customizing the search in a way that makes sense for your business. You're also able to come to the market much faster. Taking natural language models, building them, training them requires a lot of effort, gathering a lot of data. But we have done all the heavy lifting on your behalf so that you can get started with a highly accurate search on day one. There's also a chance of or possibility of getting a new revenue stream. We've come across some customers who are saying, well, not all of their customers want a semantic search, but some of them do want it. So they give an option and say, well, okay, if you want semantic search, you can pay a premium. That means added revenue for you, more revenue streams for you, and also better experience for your customers. So let's look at a couple of examples of contact center application and a chatbot application where you can use Kendra. So at the top is the contact center application. where a customer is calling a contact center agent who's trying to resolve an issue real time. While the conversation is happening, Amazon Transcribe is continuously monitoring the call, taking the transcript and passing it on to Lex. What Lex does is it takes that information and generates smart suggestions for the agent to be able to interact with the customer. And if it has, Lex has predefined slots which can tell you, well, for this action, for this question, suggest this action. But if there is an open-ended question, that's when Lex will forward that question to Kendra. Kendra will look at the document corpus and generate smart answers or suggestions for the agent to be able to resolve the customer's issue. There's also another path that goes to Amazon Comprehend, which will extract the entities and key phrases from the transcript, send it to S3 that can be used for post-call analytics. Now, the similar setup can be used for chatbots as well, where you have a customer that is interacting with Amazon Lex. Lex will use predefined intents. If the customer's queries fall within those intents, Lex handles it on its own. If not, it sends the query to Kendra, and Kendra will use whatever knowledge base articles that have been indexed into it, search through it, and surface that relevant answers to the customer. So let's look at an actual example or a demo of how this can be used in a contact center application. So for context, what we have here is a conversation between a customer and an agent and a live call analytics solution in play. So the customer is calling a bank to resolve a credit card issue. And they start with that, and then towards the end, they ask about questions like what kind of insurance you have, and specific questions about insurance, where Kendra will jump in to help the agent to find answers.
Hello, thanks for calling Acme Bank. My name is Babu. How can I help you?
Hi, I'm calling about my rewards card.
Excellent. Give me a second to look up your customer account. For verification purposes, can you please state your first name?
So as you can see, there's three entities here. There's the caller, there's the agent, and there's the agent assistant. So the agent assistant here is essentially Lex. In this case, it is using a predefined intent. As soon as the caller starts, they say, I'm calling about rewards card. Lex is finding the intent and giving the prompt to the agent to ask for more information. It also says that the user could be Bob based on the caller ID lookup. Now I'll jump straight to the part where Lex forwards the question to Kendra because it's an open-ended question, and Kendra will search through a repository to surface the right answer.
Can you tell me what kind of...
From your checking account, is there anything else I can help you?
So this is where the agent has resolved the issue, and now the caller moves on to another question.
Can you tell me what kind of life insurance policies you have?
Yes, of course. I'm just pulling up our latest life insurance policy information now. We offer many types of term life insurance and permanent life insurance, including whole life, universal life, endowment policies, accidental death policies, and more.
Interesting. What is an endowment policy?
Let me look that up for you now. It's a life insurance contract designed to pay a...
So as you can see, the two questions that were asked were not predefined intents in Lex. It was open-ended questions. One was what insurance policies you offer. The agent assist suggestion actually came from Kendra. Then the user, the customer, went to ask another question about what is an endowment policy, and that descriptive answer also came from Kendra. And the agent is able to assist the customer in real time. Now, what this means is, you have a great caller experience because they are quickly getting the information that they're looking for. A great experience for the agent because they're not spending time wasting productivity in trying to find information. And very good for the contact center expenses because they're able to manage more calls, save time with improved productivity. And all of these use cases or use of Kendra can be translated to many different types of SaaS applications as we talked about before. So with that, I want to hand it over to Justin to talk about how you can sign up for a POC and also resources that are available for you.
Thanks, Nikhil, and fantastic demos. It's so great to see the power of Kendra in action. I'm hoping that our people in attendance today can visualize what their organization's data might look like in this type of structure, what type of use cases might be needed to really flesh this thing out. So let's talk about how we can enable you through a proof of concept here with Amazon Kendra. We'd obviously love an opportunity to discuss with you via discovery call to get to know your business and understand where Kendra or any other Amazon Web Services products may be of use for you and your company. Let's start off by offering white glove support. That's really my contribution to this particular endeavor, is to work with you one-on-one to ensure that you succeed your way through the pipeline of adopting Kendra. We've made it very easy to do so, but we understand that many organizations of different sizes have different needs, and we want to work with you to get you a solution that works perfectly for your organization. Secondly, we do have POC credits available for you over the next few weeks. We have a really time-bound engagement here for our push towards ISV adoption. And my time and resources have been allocated to be able to help you with that. And so we have some resources available to defray cost on your POC for up to 3 months as we get you up and going with a solution that works for your business. Third, we have go-to-market activities that can really help you depending on your use case. We can co-author blogs detailing our partnership together. We can provide AWS representation for customer-facing engagements, things like webinars, if those are helpful in pushing your business forward. And then lastly, partner enablement, whether that be on a technical side or a sales side. We'd be more than happy to try to put you in front of the right people to ensure that you have a successful product through your embedded search offering with Amazon Kendra. Next, let's go to our Q&As. Many of you have submitted questions into the chat, and thank you for doing so. We've got time to get to about 7 of them today, so I'll go ahead and pull up a few. If you do have questions even now, please go ahead and submit those. As I mentioned earlier, I'll certainly get back to you via email with an answer to your question, whatever it is. There were some common themes and questions. We'll try to bring some of them to light, and I'll bring Nikhil back on to answer some of these. Nikhil, thanks again for walking us through Kendra. I think it's a fantastic product, and I think the questions that we're getting so far have been very positive, and people who are interested in learning more. So let me start with this question. How long does it take to set up and deploy a search solution using Kendra? I know you mentioned faster time to market being a strong selling point for Kendra. So how long are we talking to get up and running?
Yeah, that's a good question. So the time it takes to set up your search solution on Kendra really depends on 3 things. One is where your data lives. Is your data ready to be indexed? And how much content you have? That's one thing. The second is how much do you want to tune and customize your search results? Whether you want to do simple tuning, do some testing, and just launch it, or you want to use advanced customizations using document enrichment, or even your own custom code. And the third thing is, how you want to track the search performance for your users. If you want to build, if you want to track very advanced things, that takes longer. Versus if you want to get started very quickly, that will take much shorter. So, as an example, all of the demos that we saw earlier that involve crawling of websites, Wikipedia pages, or our own documentation using a web crawler was an effort of a few hours to some of them maybe taking a day or so. So I hope that helps get some idea of what it takes to use a solution or deploy a solution with Kendra.
Yeah, along those same lines as timeline, how much time or training is needed before you begin seeing strong results?
So Kendra is actually built in a way that you don't need any machine learning expertise. You don't need to train any models. Kendra's natural language models are actually pre-trained for 14 different domains and industries. It has been trained on thousands and thousands of different queries and documents and answer sets to be able to give you that accuracy. And it cuts across those domains so that Kendra is able to handle the nuances of each domain very proficiently. We do have the incremental learning feature in Kendra that tracks user behavior to make results better. Now that it takes maybe a few clicks for that to start improving the results. But that said, even without incremental learning, the baseline accuracy that you will get with our natural language models will be pretty high. Again, going back to my example in all of the demos that we saw, that it hardly had any incremental learning to it besides the demos that I've been doing. And you still see that it was surfacing very, very relevant results.
Great. This is a question we got a lot of. How do I bring my data into Kendra?
So there's we have the 3 different ways to bring the data into Kendra. One is using our pre-built connectors. So we have about 17 different connectors, native connectors in Kendra for very popular data sources like Confluence, OneDrive, Google Drive, SharePoint, Box. So if you have content in even a web crawler, so if you have content in any of these data sources, you can use our connector to say, well, here's my data source, point the connector to that data source, and Kendra will go and crawl the entire data source, take the documents and put it into our index and make it searchable. So that's one way. Then we have custom connectors where you can build a connector that can go and crawl your data source if your data source is very, very custom or something that's not supported today. By the way, we have 17 connectors that are native. We have 100+ connectors from partners that cover multiple different data sources. The third way is to use our batch put document API to directly send the document into the Kendra index. You can send in batches of 10, and you can use that, integrate that API into your ingestion pipeline, and it will put the documents into Kendra.
Great. And what languages does Kendra support?
So today we support, for semantic search, we support the English language. And in addition, we support 34 additional languages for keyword search. We are planning to add semantic search support for a lot more languages in steps, and you will see support for a few languages coming in later this year for semantic search.
Thanks. How do I manage performance and availability with Kendra?
Yeah, very interesting question. Often teams that manage search, they'll always have this question about, who is taking care of the performance. So that's the advantage with Kendra, is that we manage the search performance for you. So we make sure that the query latencies are within a certain limit. We ensure that the search infrastructure is actually distributed across multiple availability zones within AWS. You always get 3 nines of availability, and all of that work is completely abstracted away from you. If there's if the latency goes high, or if there's something wrong in the infrastructure, our teams are managing all of that on your behalf. And that enables you to focus on things that make more sense or add value to your organization, which is to make the search customized to your business needs.
Our next question is, what types of questions can I ask Kendra?
So as you saw, you can not only ask, you saw a lot of questions on natural language questions that I asked in the demos, but we also saw that you can also ask keyword questions, and it will still find semantically relevant content. And that's because we've trained Kendra to be able to take any type of queries. And because users, when they come, like many users are just trained to, or they've been so used to asking keyword queries that they may not always ask a full question. But Kendra has been built in a way to still be able to figure out the search intent. In addition, we also have features or query languages that users come to expect with search engines. Like, for example, you can use Boolean, you can add and, or, not. You can use parentheses to create complex expressions. You can do a prefix search. You can also do exact matches using double quotes. And you can also add rechecks to your queries, so that if your users are advanced, if there's something very, very specific they're looking for, so they can build a very complex query using natural language, keyword, as well as the structured query language that we have support for in Kendra.
And our last question today is, what if my data does not contain the precise answer Kendra's looking for?
So, that's a very, very probable scenario where users looking for something, it doesn't have, your documents don't have the answer. So in this case, as you saw, when I asked, when I showed the well-architected framework demo, in that case, there wasn't a specific question, so there was no answer. But in that case, Kendra will still return documents that are semantically relevant to the user's query. So that the user can go and find the information that is in your corpus. Now, the other side of this is also that if a lot of users are asking this query, if a lot of users are asking the same query, then you will see that in the analytics dashboard, and you can start creating content that is relevant or that is answering the user's question. And then you will, Kendra will start using that to generate relevant answers for your users.
Awesome. Thanks to everyone who submitted a question today. Again, if we did not have a chance to answer your question, we'll get back to you via email. Thank you all for being in attendance on behalf of Nikhil and myself. We do have a way for you to get in touch with us. The email address listed here on the screen, aws-kendra-customer-interest@amazon.com. We will be so delighted to help you fit your business need with Amazon Kendra for embedded search. We hope this has been an informative webinar series here for you. We look forward to answering your questions, so please feel free to reach out to us anytime. And again, on behalf of Nikhil and myself, thank you for attending.
Thank you all for your participation.